Okay, so hey guys, so today we'll be talking about our experimental proposal. We will be covering the experimental objectives and background and our three experiments and the procedure, hypothesis, and material lists. So our main objective is to analyze how liquids behave in microgravity environment, and when gravity-driven forces like buoyancy and convection no longer apply. So in this circumstance, surface tension and attention and diffusion are the dominant factors. So we will be investigating specifically the transfer, mixing, and separation of liquids in microgravity environment. So we divided our experiment objective into three sub-experiments. The first experiment, experiment A, and our goal is to focus on the liquid transfer between two connected containers in microgravity. So on Earth, gravity drives liquid flow, and when this force is absent, the surface tension takes over. And so for this experiment, we will connect two transparent containers using tube and inject 70 mole of colored water into one container and flip it to stimulate pouring. Using a higher resolution camera, we can observe how the liquid flows from one container to the other. And this is our experimental list and procedure, which we will not be diving into today. And for experiment B, we aim to investigate how two immiscible liquids, for example, yellow and blue dye water, mix in microgravity. And we will use 7 mole of yellow dye water and 7 mole of blue dye water in a transparent container. This way we can observe when the two liquids mix together by analyzing the color change. And this is our material list and procedure. So the key observation for experiment B will be the formation of green color and how it diffuses in microgravity environment. And for experiment C, we will be investigating the interactions between two immiscible liquids, such as oil and water. So on Earth, gravity creates oil to float above water, and it creates layers. In microgravity, this is not the case. So we want to investigate how immiscible liquids interact with each other in space. So we will be using oil and water. And this is the material list and procedure for experiment C. Yeah, and the key observation for experiment C is the droplet formation and the distribution under microgravity.
Here's our hypothesis for experiment A. In a zero-gravity environment, water transfer governed by surface tension and cohesion rather than gravity on Earth. Liquid relies on hydrostatic pressure, where delta P equals to rho times gravity times height, generated by the weight of the liquid column. In microgravity, where gravity equals to 0, this pressure gradient becomes negligible, where delta P equals to 0 and surface force dominates. Liquid adhere to the surface, forming droplets instead of flowing smoothly. The law of energy conservation dedicates the sum of gravitational potential force and kinetic force. In microgravity environment, G equals to 0, where the velocity of the liquids will also be approximately 0. So the liquid won't be able to move. The hypothesis of experiment B. In microgravity, moving two miscible liquid depends entirely on molecular diffusion, as the convection driven by density difference is absent without gravity diffusion, results in a gradual concentration gradient described by Fick's second law, where partial derivative of C over T would be okay, so the diffusion time will be determined by T equals to L squared divided by T. And so for T equals to 6 times 10 to the power of -10, which is the maximum. So T will be 7 minutes to 20 minutes. Thank you.
好，谢谢参赛者的报告。